What's up, everyone? This month's study club is about really chairside milling. We're calling it CAD CAM, but as we'll talk about in a minute, CAD CAM can really mean a few different things. So, what we're really focusing on is the current state of chairside milling or milling in general, and whether the transition is happening, whether printing is ready to kind of take the throne of chairside single visit dentistry, if you will. And so that's really what the discussion is all about. The current state of CAD CAM, where are we now? Where are we heading? Because, when we think about chairside CAD CAM, it's really where a lot of us started in our digital journey. We wanted to transition to single visit dentistry, and really milling was the way to go, right? For the last, I don't know, for us, it's been 15, 16, 17 years since we adopted that technology, and it's come a long way in that time period. It's been really great for our practices and for the way that we do dentistry. But in all things, right? All good things must come to an end. And so we'll really talk about is this technology one that is on the decline rather than the ascension? All right. And so let's get into it. So when we talk about CAD CAM, it's important to understand what we're talking about. Right. And CAD CAM stands for computer aided design, computer aided manufacturing. And really, some of the advantages in adopting this in your practice are the ability to do single visit dentistry, first and foremost, is a huge practice builder. I don't think you can talk to anybody who uses this technology day in and day out who will tell you that it has not benefited them in their practice. Control. You get control of the entire process, right? You're essentially taking over the mantle of lab technician, doing the design, doing the milling in this case, and any staining and glazing that has to be done. You've got total control of that process, which for some people can be a little daunting, but for us, we found it really freeing to know that when we sat down to deliver that restoration, that it was going to be perfect. And that if it wasn't, it was something that we could look back on to change. Was it, something in the prep? Was it something in the design? Did we add too much glaze so it's not seating, or we had to adjust the occlusion? All those things you can refine. And as you get that process dialed in, what you find is that delivery is super simple and predictable. And we all love simple and predictable in our practices. Another advantage is cost, right? Once we start to really scale this, you find that there is a little bit of cost savings in the process. Now, a lot of that depends on how much cost you took on upfront to purchase the technology, the types of materials that you're using, all those things. But in the grand scheme of things, when we're talking about costs, we're not talking necessarily about things like material costs. We're talking about like process costs. Like as you scale this and going from 2 visits for posterior restorations, for instance, to 1 visit, there's a cost savings in that for you not having to set up the room an additional time to just do a delivery. Essentially, there are cost savings that you take on in that regard. So while there are costs that are disadvantages, the upfront cost of buying a chairside milling system, there's also cost advantages for implementing that within your practice. So those are kind of the 3 big advantages. The disadvantages are the responsibility. Like I said, if you are taking on the responsibility of being the lab technician, that's on you. So if you're doing bigger cases, for instance, and maybe you're doing bigger cases in multiple visits, you have to set aside time to do the lab work to get ready for that delivery appointment. And I know a lot of us, we don't necessarily do everything single visit. As we take on larger cases, sometimes we'll do those in multiple visits just to be able to take a little bit of time on the lab work to make sure our ceramics are really pretty. We have a saying around here at the Mod Institute: don't rush the art, right? You really want the level that you're delivering to be every bit as good, if not better, than what your lab can deliver. And so sometimes it's worthwhile to take a little bit of time to do that, particularly for bigger cases. The startup costs are definitely a negative. A CEREC system, for instance, goes for $150,000, $160,000 for that system. You can 100% make up that money if you implement that technology and commit to using it in your practice, but it can be a tough pill to swallow up front. And then there is some material knowledge as well. So, usually we send something to the laboratory and we can rely on them to pick the best material for that case. If it's a second molar crown, they're probably going to pick zirconia. If it's something in the smile zone, maybe they pick Emax or a lithium disilicate or silicate of some sort. We take on that responsibility now. different translucencies of material, different shades. You gotta shade match accurately. You gotta know, if staining glazing is necessary in order to create a restoration that's camouflaged within the oral cavity. All these things are up to you as the dentist or your team, whoever's doing that lab work and or making those decisions. And so it's important to understand that that's part of the learning curve, right? You can't just use essentially one flavor of Emax for everything and expect to get a good result. Sometimes you need to use a high translucency. Sometimes a low translucency is better suited, and knowing when to mill those blocks is part of that learning curve. So there are definitely advantages and disadvantages to using this technology. But when we talk about the manufacturing part, the M in CAD CAM, it equals milling in this case, but it also equals printing. And we'll talk about some pros and cons just briefly between milling and printing when we're essentially creating restorations. And the milling process requires machining of a material, right? Whether it's lithium disilicate or Emax or whatever, there's pros and cons to each of those approaches. But when we're milling Emax, for instance, and Emax in block form has been the gold standard, I think, in CAD CAM over the past 16 or 17 years in my entire career, essentially. These are milled with diamonds, and these diamonds are relatively large diameter tips from 1 to 1.2 millimeters for the most part. And what that means is that you essentially have a large burr milling out the intaglio surface of your restoration. That can affect essentially how well your restoration fits. How much material thickness you have. We'll go into a little more detail on this later, but a bigger burr essentially is less forgiving versus carbide burrs that are used to mill zirconia, whether it's in puck form or block form. These carbide burrs tend to be a little bit smaller in diameter. Okay. The other thing about that is zirconia mills about 20 to 25% larger than its final size. So even though you have a burr of a certain size, you're essentially milling something that is 20% larger than the Emax equivalent would be. And so you get a lot more detail, you get a lot more forgiveness from these smaller carbides milling zirconia than you would from a diamond of a millimeter or so milling Emax. So it's just important to understand the differences in that manufacturing process. For 3D printing, we're essentially creating the restoration with a photon of light or a laser, right, of some sort. Essentially, it's light that's creating that in a certain pixel size. Nowadays, the pixel size is about 0.025, so about 25 microns, very, very small, quite a bit smaller than the burrs that we would use to mill our restorations, even the smaller burrs that we would use to mill zirconia. So what we get out of this is a lot more detail. We get a lot more forgiveness when we're essentially machining or manufacturing the intaglio surface of a printed restoration than we would from a milled. So this is one of the benefits when we're comparing these two modalities is we do get a lot more detail and we're able to replicate our prep much more closely regardless of the shape and the angles and things like that with printing than we would with milling, which is an advantage, I think. The reason that's an advantage is because we no longer have to really give as much thought to the geometry of our prep because it's not limited by tool size with printing as it was with milling. Okay, you often heard if you're chairside milling or even if you're sending to the lab for any sort of ceramics, particularly lithium silicates or disilicates, that you needed to have a prep that was without sharp internal angles and nice and rounded and smooth. All right. And the reason for that is because of the nature of the material. Okay. The sharp internal angles can cause stresses within the ceramic. The other thing is that when we have those sharp internal angles, the burr size that we're milling, being at around 1 millimeter, means that it struggles to replicate exactly those sharp internal angles. And what we get is something called overmilling, where it has to mill more of the ceramic out of the intaglio surface to make sure that our restoration seats all the way. This just means that if you have a certain amount of distance between your prep and the opposing tooth, if that machine overmills your ceramic and you think you have 1.5, for instance, you may only wind up with about 1 millimeter because the mill has over machined the intaglio surface of that restoration. So it creates a thinner restoration than we maybe expect if we have sharp internal angles of our prep or sharp angles in our preparation. So we don't have those limitations quite as much with 3D printing, which is nice. The other thing is now puck milling has become more and more popular. This is the idea that instead of doing a single block, milling a single block of a material, we now have a puck where we can mill multiple restorations out of a single puck. And this is a much more economical approach to milling. The mills themselves are relatively, I would say, similarly priced to chairside mills in that they're in the maybe 25 to $50,000 range, or you can even buy some nicer ones, obviously, that are a little bit more expensive. But for just a single puck mill, you can get them for about $35,000. And for these, any single puck of zirconium material runs anywhere from, say, $100 to about $300, depending on the quality. And you can get about 20 or so restorations out of a single puck of material. So you're talking about a really nice cost per restoration that you can essentially have or realize with puck milling. The other thing about this is you can mill arches like you see here. We do this all the time here at the Mod Institute, and our lab Mod Restorative Studio does tons of arches where we're churning out people's all-on-X prosthetics for them as part of that digital workflow. And it's really cool to be able to see these prosthetics come to life. Um, Understand that, like I said before, these prosthetics mill about 20% larger. And then they have to go through a very long sintering cycle, multiple hours, usually around 10 hours or more of a sintering cycle to essentially be the finished product. And then you apply some stain and glaze, usually in the form of Mio or something comparable to Mio, to really bring those restorations to life. But it's a process that is a little bit labor intensive to do. It takes some skill, takes some knowledge and know-how, takes an anatomical an eye for the anatomy of what things should look like, both in shape and color. But it's a really cool thing to be able to do. And once again, when you're talking about a return on investment, puck milling really does give you a nice return on investment. In the green state, which is what you're seeing here on the screen, zirconia is almost like a hard chalk material. It's very fragile before it's gone through that sintering state, but it's very easy to work with. So you can make little refinements within the anatomy while it's in that green state, if you do so very carefully. But then once you're done with that, you can sinter it and then add stains and glazes to make it look really lifelike. So like I said, we do this all the time in our Mod Restorative Studio. We have our veneer residency coming up next week, where we'll be delivering some zirconia veneers for one of our lovely patients. This is an example of a case that we did a few residencies ago. But you can see you can get some really beautiful results using the combination of a gradient translucency zirconia and some external staining and glazing. And it's really efficient. Like I said, $10 per restoration or so is about what you would pay. And then obviously there is some labor involved to get it to look really beautiful. Here's that finished case delivered. So really, really nice. So once again, looking at milling now, a lot of people are still loving their chairside mill systems, and for good reason. The materials are time tested. We know exactly what we get. They're really durable. It's that the workflow is predictable, right? There are some advantages and disadvantages to that, but a lot of people are loving that workflow. And I think we are amongst that group. We love chairside milling. We have for many, many years. But we also realize that we're starting to transition a little bit away from milling into printing, because that's initial startup cost of buying a CAD CAM system, with CEREC being the market leader, is about $150,000, $160,000. You can get a Midas, an intraoral scanner, a NanoCure for less than $30,000 now. So the startup cost is significantly different. This is going to bring this technology to a lot more people, make it so it's a lot more of a widely adopted practice. Chairside milling only ever got to about 25% of dentists who essentially adopted that technology. We're hopeful that 3D printing will be able to reach a larger audience. So a lot of things to be excited about. Once again, not talking bad at all about chairside CAD CAM. We love it. It's very predictable. It's a wonderful workflow. We're just starting to see a little bit of a change in the market, right? And I think a lot of that has to do with the startup costs for that technology. Let's talk about a case real quick, and this is one that I did a few years ago, if I'm honest. And I like to, it's interesting to present cases because when you look back and as you learn more and as you grow in your career and gain more experience, a lot of times I'll look back at these cases that I thought, man, I did great on this. And I look back and I'm like, this is not as good as I originally thought. Or man, I wish I would have done this differently. And this is one of those cases. So this is a patient who came in. Some of you may have heard me present this case before. But I want to present it a little bit differently. This was a patient who came in at an existing veneer on tooth 1-1 or number 8 for those of us in the States, and had chipping at the margin. And this is relatively common for certain types of preparation. This is a prep error, and we'll talk about what that looks like here in a minute. But this veneer had been in the patient's mouth for about 7 or 8 years. And she had had this whole ordeal to get this veneer made where she was flying across the country multiple times for try-ins, having to send the veneer back to the lab to get it remade. Anyway, it was this whole ordeal. And she came to me with this in the situation that you see on the screen. And I told her, look, I don't have time to deal with this today. She was an emergency patient. I got her scheduled for a week or two later. Took my initial photos and said, I'm going to see if we can do this in a single visit. So it's the benefit of having the technology. Let's see if we can put it to use. And she was like, all right, that's fine, but I doubt you'll be able to do it in a single visit. The last time it took me like 4 or 5 visits. And I was like, well, that's fine. We'll see what we can do. So she came in and took the old veneer off, and this is what I found. Now, this is a very aggressive veneer prep. This is actually more of a 3/4 crown prep. I wouldn't even think of this necessarily as a veneer. We don't have any more enamel left. All right. Once you get through the enamel, in my mind, it's not even really a veneer prep, regardless of how where those margins are and things like that. Now, I just went ahead and we remade this as a veneer. But part of me, as I've gone forward in my career, and I did this case probably 8 to 10 years ago, I almost feel like I could have turned this into more of a circumferential prep, something called a cingulum preservation prep. And the reason for this is because when you have no enamel on the tooth, your bonding predictability goes down. And what happens is that as that bond starts to deteriorate, and that generally happens the 8 to 10 to 12 year mark, is when you start to see problems like chipping, for instance, at the gum line, exactly what she experienced, right, with her previous veneer. What doing more of a circumferential prep does is it gives you a little more retention and resistance form. You're able to essentially limit how much those forces affect the overall restoration because you're giving it some mechanical stability along with the adhesive stability that you gain from your bonding agent. Doing this, like you're seeing on the screen with these cingulum preservation preps, helps to maintain a lot of the strength of the tooth. It also gives you a ton of enamel on the palatal side to bond to. So it's a really nice kind of a compromise when you have patients who've already had a really aggressive anterior veneer prep, that you can still give them a conservative solution, but one that has maybe a little bit better longevity than just re-adhering this to dentin on the facial. But I didn't. I kept this as a veneer prep for this case. Once again, hindsight always 2020, but did my digital design. The great thing about a lot of the design softwares that we've really had for years is the ability to mirror anterior teeth, and it makes the design portion of these very simple. We're able to give ourselves a mirror image, particularly important when we're working on the central incisors. And then it's all about being able to recreate the coloration and the texture. Texture is super important for this case because if you look at her old veneer, there really wasn't any texture on that. It was they did pretty good with the staining and the glazing, but they missed on the texture. And what you're trying to do more than anything is not to get a perfect result. People think they need this to be perfect. It doesn't need to be perfect. And we'll talk through how mine in the end wasn't perfect. All right, but it does need to be camouflage. And camouflage is important because you need to obviously get the shade close. You need to get the value right. Value is the most important thing that you need to capture, but you also need to get the shape and the texture correct. And our software helps us get the shape. All right, texture is just something that takes a little bit of skill in the processing portion to do. It's not so difficult once you learn. And it's these details that help take something from being an okay restoration to something that is really good and really camouflage. And when you're at a speaking distance from the patient, is totally invisible. So obviously things that are important are the prep shade as well. Things that you need to think about when you're the CAD CAM dentist is what is the underlying tooth structure? What color is that? Because modern materials are translucent. So if you have a darker prep, right, you need to counter that darker prep maybe with a lighter cement or a lighter shade for your ceramic to offset the darker prep shade. Okay, these are things that if you've only ever sent to your lab that you may have never thought about. The ceramic translucency, right? Emax, I always use Emax as an example. It comes in high translucency, medium translucency, and low translucency. Those are all great options to have for different types of indications, okay? The thickness of your ceramic will also dictate how translucent it is. Obviously, something that's really thin is not going to block a darker prep shade as well as something that has a little bit of thickness to it. And then chroma change and incisal characteristics, particularly important for anteriors, right? You need to be able to add whatever level of staining and glaze that you need to in order to help it to be camouflage. And a lot of times in the anterior, that means a little bit of translucency, right? Which we use blues and grays to bring that out. But to just make it so it looks like the adjacent tooth. All right, in this case, we'll look at what I did for this case. I didn't need much in the way of translucency. Sometimes the block or the material itself gives you naturally some translucency. So you really, it's part of the learning curve is understanding what the ceramic will look like once it's out of the oven, and then allow you to predict where you need to add stains. Okay, and texture, once again, if you look at this case, texture for the previous restoration was not correct. There was no texture. Okay, so we need to make sure we can add texture back to our glaze layer after we fire it to make sure we have a nice match. Okay, and this is what we ended up with for this case. Okay, it's not perfect, and I'll tell you a couple of things. That space for number 8 is more narrow than the space for number 9, but you can tweak the line angles very slightly to trick the eye that those are the same size. And I think we did a pretty good job there. If you look at the overall color of that restoration, the value, it's very close, right? So that comes down to using a low translucency or a medium translucency block. It's easier to control the value on those than it is something that's a high translucency. And then adding that texture back in once we glaze. Our glaze gives us a smooth layer. Going back in once that's gone through the oven and just adding that texture back in with a fine diamond and then just hand polishing that surface to make sure that it's nice and smooth. That's all that works to give us something that looks camouflage, okay, which is exactly what we are trying to do. So once again, I don't know if I did the right thing by leaving this as a veneer versus taking this to a cingulum preservation prep. We can look at the before and after. It's been eight years now. So far, so good with this patient. But once again, you can generally expect a bond to dentin, depending on the stresses that restoration's under, to last anywhere from 8 to 12, maybe 15 years now with more modern adhesives. But this is what we can do with chairside CAD CAM. And I didn't do this in the first year that I was doing CAD CAM, right? I built towards it. I started out with single unit posteriors, right? Started doing more quadrant posteriors and then added in anteriors as we got a little bit better at the workflow and more comfortable with the ceramics. So I'm excited for you guys to hear what our group has to say. You know, it always gets a little bit rowdy with these guys, but these are all, once again, we're all lovers of this technology. We're all lovers of technology in general, but we're all specifically lovers of this technology. A lot of us came to digital dentistry through chairside milling. And so I'm really excited to hear what your thoughts are on this technology. Is it dying, right? Will it kind of maintain its 20 to 25% adoption rate over the next, say, 5 years, even as printing grows? I'm really interested to hear what you guys have to say. But first, we're going to hear from our panel, all right? Looking forward to hearing your thoughts. Thanks.
Why don't you just clip it to your crease?
Yep, check.
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 Testicles. Who's supposed to be checking what?
Put that pastry spread in front of that cream drink.
What is that, rum? Bourbon?
Maybe later this afternoon.
Yeah. What's up, everyone? I'm here with my distinguished colleagues. We're going to talk about one of my favorite topics. Honestly, the thing that that got me most excited in dentistry in the past 15 to 20 years is CAD/CAM dentistry, chairside milling, single visit dentistry. But it's something that I think is, I don't know, maybe dying. And so that's what the discussion is here today. As technology transitions, is chairside CAD/CAM a dying technology? If you're a new graduate, if you're looking to start a practice, is this a technology that you want to implement and purchase? That's what the discussion is going to be. And I'm with some CAD/CAM enthusiasts. I know Wally's been doing CAD/CAM even a little bit longer than I have. So let me start with you, Wally. First of all, tell me what you absolutely love about chairside milling.
I mean, one of the most profound things as a clinician to have is control over the complete process. And for me, the thing that really excited me was to be able to do conservative adhesive dentistry in a single visit and have complete fundamental control over occlusal contact locations, proximal contact strength, the aesthetics, and then to be able to deliver that in a, what I would say is a very efficient manner, hour and a half appointment, was revolutionary. It absolutely changed the trajectory of my career. It made me enjoy dentistry again because, I mean, I was like, I don't know if I really love dentistry. And the digital technology fundamentally made me a better clinician because, you know, when you see your preps and you're marking your own margins and you're looking at your stuff day in and day out, you're your own worst critic. You're calibrating yourself, you're getting better, and your patients are benefiting from that. So to me, there is no such thing as dentistry without some form of CAD/CAM, whether it's milling or printing or who knows what's coming in our lifetimes. I've seen some really cool stuff that could just generate stuff out of the ether. So it's like, what is exciting to me about it is that it is dentistry. I could not imagine the profession without it.
Yeah, I think we talk about it as a subset of dentistry, but for us, it's the norm. I couldn't practice without
Yeah,
it.
it's how I practice.
Yeah, let's talk about what you have and
I mean, I immediately
do.
fell in love with it, right? So I have a chairside mill, and that's like every day, all day long, inlays, crown lays, and I, have been doing it at such a high level. I transferred into doing anterior aesthetics, and so I do all my own lab work with veneers, whatever it is. Like I throw it all in there.
That is legend level, yeah.
And it's just so fun. And going on Wally's point of how rewarding it feels and how it makes you a better clinician. I mean, I don't think it's going anywhere. It's just going to evolve and change. So maybe you're not doing single unit chairside, glass ceramics, and maybe it's going to be some new wonder printed material, right?
Yeah.
But still, it's the same workflow, the same idea of control and quality, right?
What's funny for me was going through the evolution early on and having the naysayers be like, oh, you're never going to get a good fit. It's just a temporary, the margins are all bad. You're doing bad dentistry. You're doing malpractice. You're not pushing the profession forward. And now I look back and I'm like, I'm glad I just ignored all of them.
Yeah, I mean, well, that's like anything though. There's if you don't know how to use the tool correctly, good in, good out.
I mean, certainly, but that's the same thing with, I see lab fabricated crowns that are like
that's
terrible.
just dentistry. It's not specifically CAD/CAM.
Of course.
Well, yeah, I mean, and I think back to your point, when I started doing, chairside dentistry, I realized that I had a long way to go to be the clinician that I thought I was. And I think this is probably, especially at that time, was what is intimidating for people who've been practicing a long time. And they try CAD/CAM, well, they realize that now you're not casting into a margin that looks like this. A tool is going to mill a smooth margin. So if you put a smooth margin there, yeah, the fit will be perfect. But if you're used to a really skilled lab technician making up for some clinical inefficiencies and issues, you don't have that, right? The safety blanket is gone.
Castings are forgiving.
Very forgiving.
Well,
CAD/CAM is not.
you make a good point though, Mike, because lab technicians make dentists look like heroes every day. Dentists that probably shouldn't even be practicing dentistry, to be honest with you. But I mean, the issue, and honestly, I've been there. When 20 years ago, it was over 20, when I started my CAD/CAM journey, I'm an old man, yeah.
It's all that gray hair, man.
I'm basically ancient. But when I started, I thought I was like, good as a clinician. And then I got my first restoration out of the mill, and it didn't fit at all. And what is the first thing I do? Friggin' the mill is stupid. You know, the mill don't work. Oh yeah, you know, nothing. But then what happens is a switch flips inside of you, where you're like, hey, maybe it's not the scanner, maybe it's not the mill, maybe I need to get better. And that was my career. It took my career, and I just went, I'm just gonna get better every day. I'm gonna strive for that, and I'm still not there. I still look at my stuff, and I'm like, come on. I'm like, but if I look at what I do now compared to what I did then, it was CAD CAM that caused me to peak and to get better as a clinician, because so many people have been doing dentistry the same way for 20, 30 years. Yeah. They slap an impression and they got a scanner, so they think they're digital now, but really they're just doing the same old stuff, but now they're scanning it and sending it off somewhere. To me,
To make their PFMs?
to their monolithic zirconia crown, which is also
yeah.
making people look like heroes. And I'm not to sound egotistical, because I've never looked at any of my work ever and been like, I nailed it. I always find stuff that I want to improve. But when you are a clinician and an artist, and you go from prep, scan, design, and delivery all yourself within your own team, something fundamentally changes.
Well, there's two things that change. One is you can't say it's the lab's fault anymore.
It's your fault. That's the exact point, right?
Damn.
But yeah, I mean, it's so humbling the first time you zoom into that digital scan at 50x and see what your prep looks like compared to 2.5 to 5 with your loops. It's like, I have a long way to go.
But I think having it be a closed system, right? There is no scapegoat, and so it lets you go back and look. Like if you do run into a problem, what did I do wrong? Right? And hey, guess what? It's in my power to fix it. And that right there is just, you can self kind of
Immediate feedback,
right? And then two, another great thing, like let's say you didn't reduce enough occlusion, right? It's not this whole thing with the lab sending you some reduction coping, and or they're saying you need to bring the patient back or anything. You scanned it, you look on the software, oh, I don't have enough reduction. You just sit them back in the chair if you let them wander, and 2 seconds later you got the proper reduction, and you're off to the races with your design.
I never have more anxiety than if I send something out, because I don't know, okay, if this doesn't fit or see, is it my fault? Is it the prep? Is it the model? Is it the printing? Is it the stonework? Is it what is in the process that didn't go right? So I have so much anxiety going into the patient appointment of delivery, where when I take care of it myself, zero anxiety.
Yeah.
Well, and I think part of that is the changes that labs have undergone. It used to be that you had a technician who had a certain amount of skill, because it just takes a certain amount of skill to cast and stack porcelain, right? Now you have digital designers essentially who may have no formal training, who may not have all that really much knowledge in what a tooth looks like.
Well, I mean, you got a high school kid in a warehouse in Costa Rica waxing up your crown, and then
that's the reality.
they're firing it off to the lab, and all the lab does is hit mill, and then you got an assembly line of finishers, and it's like, where's the art? Not saying this in general. There's some really quality labs out there. Of course, I would like to say our lab is phenomenal. But one of the things that really, I think CAD CAM is not dying. I think it's growing, and it might be milling, it might be printing, but it doesn't matter.
Yeah, I guess in my mind, when I think of CAD CAM, I think of milling. So I would agree with you. It's not, CAD CAM is not certainly constricted to just milling. But when you look at the numbers for chairside milling, I mean, it plateaued at about 25% adoption, right? 25% adoption.
And we'll surpass that with printers this year. Actually, I think we're at 22% right now in America for printer adoption.
Well, and I agree. We'll come back to that. But why do you think chairside milling never got past that 25%?
Mills are expensive, and it's a huge learning curve and intimidating. I think it's like the combo of both of those things.
Yeah, and I would add into that learning curve though, but it, like what we've just been talking about, it requires a certain level of humbleness to own it, right? Like to say, all right, this doesn't work, I did something wrong. So in my mind, some of this I've been told by other clinicians, and I can say that I started practicing as an associate without really CAD CAM, and so I learned both, right? Like I learned CAD CAM in school. First couple of jobs didn't have it, so I really had to get into analog, and then when I brought my own practice back into CAD CAM, and so Yeah, it is like nice when something doesn't work to, instead of telling the patient, hey, I messed up, right? It's like, it looks like the lab made a mistake here, right? So,
Dirty. That's dirty.
but, so I think some of that is like just fear of change and ownership is probably part of it.
People are just comfortable doing the same old stuff. They got a workflow, and what's weird to me though is those very same people are typically burnout, unhappy. They don't love the profession of dentistry. They're in this like feedback loop of doing the same old stuff. I mean, what's weird about those individuals is they don't adopt CAD/CAM, but if they did, I think they would be much more happier.
Yeah.
That's true. We get people that come into the model all the time who are later in their careers and have just adopted some sort of technology, and they talk about how I was ready to retire, and then I got this piece of equipment, and all of a sudden I feel like I could go another 5, 10 years.
The thing that motivates me is the text messages. You've changed my life. You changed my practice. I love doing what I do now because of I'm designing. I'm actually manufacturing. I get to do the artwork. To me, it'd be the equivalent of doing dentistry without CAD/CAM would be the equivalent essentially of designing a beautiful sports car and never being able to actually drive it, just looking at it. We do stuff in our patients that nobody else in the world could do. We're doing microsurgeries down to, we're looking at 0.2 of a millimeter sometimes with magnification. But then to just pass off everything else and just, not get to see that to completion, to me, that's nuts. Yeah. It's taught in dental school. I mean, when I was in dental school, I was trimming my own dies, casting my own crowns, stacking my own porcelain, setting my own dentures. What happens though is that bruises people. They're like, oh, all that crap I had to do. And they're like, I don't.
But you went to dental school before cell phones. We need to can we put it out there?
But okay,
I think that's only really true for me, if we're honest. But
that might be true, but but I did a ton of my own lab work, and I wouldn't say I loved it.
Yeah.
But it gave me such a profound appreciation. Now kids are in dental schools and they're doing nothing. They don't look at their preps. They don't.
I think, yeah, they don't do anything with fixed. They have to do removable still. I think they're still waxing their own dentures, setting teeth or pouring up their master cast. I don't even know if they're doing that anymore. But
I don't know. I mean, I have a feeling
it's probably different at every single school.
I'm sure.
Yeah.
But I think that there's a misconception that dentists don't know how to do lab work. When in reality, I think about 70% of my undergraduate dental education was lab work.
I agree with you that I think even I came out of dental school being a little bit burned out on lab work, and so that ends up being a 4-letter word in a lot of our minds, just like the rubber dam. Like I think we're all a little bit traumatized by that, but I think obviously here.
Why are you making rubber dam the enemy here?
I love the rubber dam, but when I came out of dental school, I swore to myself I was never going to use the thing again, and now here I am using it for every single patient. So I think it's just a matter of kind of getting over that and realizing that what you experience in dental school is not necessarily what the norm is.
You got to reset, and so I mean. Milling has flatlined, like you said, at 25%, and it's not growing. It's actually slightly decreasing. And I think it's because of the expense, the learning curve, and, quite frankly, people don't know what they don't know. They don't miss it because they don't know to miss it.
Well, it's only applicable for one thing, too, right? Like, that's the issue, too. So it is.
That's a pretty popular thing.
Yeah, I mean,
right?
a lot of
thing that we all do and love to do, if we're honest.
True, but I mean, having been in that world, right, in the PPO world and lived in that, there's definitely a lot of practices where they're probably doing way more composites than crowns or partial coverage, and they don't know that this is a way to transition, right? So they're like, they get the numbers from their rep. Well, it'll take this many crowns to pay it off, and they're like, that's so many years for me, it doesn't make sense, right? So there's that, I think, kind of stigma attached to it as well, and I know we're going to get to printing, but for me, that's part of why the trajectory for printing is like this. It's like universally applicable for almost anything you would ever do in practice, right? Which is so cool about it.
You had something you wanted to add to that?
Just going back to what you don't know, you know, like, and there's a lot of myths and things too. You know, some people, I remember when I was in dental school and when I just graduated and I was working in that practice, they had a CAD CAM system. You know, they had an old plan mill and everything. And one of the associates was like, "You're doing Emacs in the posterior?"
Blasphemy.
And I was like, "Yeah." She's like, "No, only zirconia." And I was like, what are you talking about?" And so, you know, it's just, there's also these myths that kind of
What is it with our profession? It's like, hey, what cement do you use? Is like the number one question I get asked. I'm like, it's not that hard. We have like 3 cements to worry about.
Yeah, and I mean, you can even simplify it further.
I mean,
that, right?
it's just crazy. I think that the stress points of bonding that has been one reason why people will say stuff like, you can't use Emacs because they're probably using like a resin modified glass ionomer and
That's bonding though, right?
spray and pray, bite down on a cotton roll, high five, and leave, and they're wondering why they're breaking, and they're probably like 1/2 millimeter thick. We know the magic of adhesive dentistry and being able to be more conservative, preserve enamel, bond, and seal. But people stress about that because they weren't taught that. And quite frankly, you know, 20 years of doing it, you don't think about it anymore. But I remember like the first 24 cases, I bonded the whole quadrant together.
There are
Glue
learning
and
curves.
I mean, I'm sure like there was flash everywhere, you know, and I think that stress is what makes people just want to, hey, let's just do zirconia, bite down on a cotton roll and forget about it.
I mean, it is a lot easier.
Yeah.
But again, is it necessarily better, right? We're doing a full coverage zirconia. It's a lot more aggressive. Is it better for the and then two, like back to your point, like they're either doing these gigantic composites or they're overly aggressive with doing a full coverage, you know, all the way down to the.
There's nuance.
Partial coverage is, and you take insurances, and what I hear all the time is, oh, I can't do an online insurance, just declines it.
Yeah.
You know what that is? That's how I get to sleep better at night and just do nothing but crowns and fillings. Like you go from a DO to a full coverage crown, and you're like, it's because insurance won't cover it. But the reality of it is, insurance does cover it.
I mean, you take pictures, get like one of those really cheap mouthwatch cameras.
Yeah.
And you take pictures of all the cracks, or you take pictures of where it's leaking or the decay or anything like that, and you submit those photos along with x-rays and you know, the narrative of, you know, this partial coverage restoration is the best thing for the tooth. The only other thing I could do is a full coverage crown.
Core and a crown.
Which would require the removal of healthy tooth structure.
Removal of healthy tooth structure.
I
So
mean,
you say all these things and
certainly there's just some clinicians that are not aggressive enough. See, we have to be advocates for our patients and literally go to bat and fight for them to be able to get the dentistry they deserve. And I think personally, the cop out of, yeah, insurance doesn't cover it, so I'm just going to do a crown. That's like going to a heart surgeon and they could do a really conservative incision and just replace a valve, or crack your chest open, your sternum, and open it all up and do the same thing a little bit more aggressively. And they're like, yeah, but insurance won't cover that, so we're just going to, you know, crack your chest open. To me, spinning down a tooth to a traffic cone when you could have done 4 or 5 more conservative things, to me, honestly, it eats at me. I just think it's not good.
Yeah, and you know, we talk about partial coverage a lot when we talk about chairside milling, because a lot of the people who are doing partial coverage are those who have mills
Or printers.
or printers, right? Exactly. So you know, I think that those two things go hand in hand because you have the capability of making it in a single visit. There's no provisionalization. It just simplifies the
second
process.
appointment, like
Yeah.
it's
And patients
just,
love that too.
They love it.
they love it.
They
I
love
get
it.
that this is the final. They like, even though I told them I'm going to make your final, they're sitting in the chair, I'm making it, and they're like, wait, this is the final? I don't have to come back?
I don't understand the every single office should have some type of way to make restoration same day, whether it is a mill or a printer. I honestly don't care. I mean, I've been printing all of my partial coverage restorations for the past 5 years.
But shit happens, right? Patients come in all the time with issues that
Broken teeth,
yes,
like,
that
I mean,
we can easily fix if we have that
we could
technology.
fix a quad. I mean, you could print a quad of 4 or 5 restorations in 7 minutes now. Like, come on.
Game changer.
Even if you're not, like, just take the whole emergency thing out. it's just a conversation with your patient, right? Like, one, the patient does not want to come back for a second visit because that means they have to take off of work. If they're taking off of work, either they're using vacation or they're not getting paid. So not only are they having to pay some amount usually for the dentistry, they're taking, 3 to 6 hours out of work, right? Financially, it's a better thing for the patients as well. Your treatment acceptance will go up if you have that option, right? I mean, to me, to get back to the whole thing, is just like trying to practice without technology is just odd. Like, it's just completely odd.
People think that scanning is, the secret to digital dentistry when it's manufacturing. It's production. I mean, and sure, there's always going to be a lab component needed for most. However, the inlays, onlays, veneers, and the crowns, the simple stuff that we could do with our eyes closed, for me, it 100% needs to be fabricated in office. Now, 5 years ago, I transitioned from same-day milling to same-day printing. And certainly early on, the materials weren't quite ready yet. And I still say for partial coverage right now, I actually would prefer a printed restoration over a milled one, just because of the fit and the fact that I could prep the way I want to prep and not have to worry about prepping to the tools and the burrs in the middle.
Talk about that a little bit, because that's a great point. I mean, we did a study actually that looked at, like, can your mill replicate the geometry of your prep? And there's been a lot of issues over the years, particularly as most people have CERECs and the type of mill that CEREC is and the diameter of the burr and
Three,
stuff
four
like
axis,
that.
yeah. When your restoration is crafted by photons and the pixel size is 35 microns, it's like having a 35 micron diamond machine that thing. I mean, we can't replicate that with mills.
Yeah.
And it's been proven time and time again, study after study. And for me, that means I could be more conservative in my indirect restorations.
It's more forgiving.
It's more forgiving. It's composite. I kind of love everything about it.
Yeah.
But when it comes to full coverage crowns, I still feel like a machined, milled restoration, premolar, second premolar back is probably a better restoration.
When you think about the type of dentistry that needs coverage, it's a lot of times molars, right?
Yeah.
And it's a lot of times, if we're honest, terminal molars, second molars.
Yeah.
Right. So, Mike, you're the resident expert on puck milling, right? So let's transition a little bit from chairside mill to puck mill. There's a lot of people now who are purchasing puck mills for their practices, or because now there's a little bit more of a group practice mentality where you have a group of practices that are all in the same geographical location. You have a centralized lab that you can use for puck milling. Talk about the advantages of puck milling over, sending something to a lab.
Yeah, I mean, I think there's, to get back to the question, I don't think milling is dying as far as the application. It's just changing, right? And back to what Wally was saying, with partial coverage stuff, I fully believe that printing is better at this point, because now we're not constrained by tools, right? Not only the size of the tools, but the path of the tools, right?
Screw size, which is a pain on a lot of modern mills.
Real quick about that though, because I still do a lot of same day, single unit. A lot of my patients only can do one onlay at a time, kind of thing, right? And it comes down to forgiveness of preparation design, right? So if you have really good smooth preps, if you have good geometries while you're prepping, you could still be super conservative and mill it out. So
Yeah, that's true.
just saying, but it's harder.
It's a learning curve, right? Like,
Yeah,
and
it's
so
harder. It's harder to execute.
technology as a whole, if you look at things that are adopted when they've really gone logarithmic, it's because they got way easier to do, right?
Exactly.
And so if you can, and I totally get your point, but there's a lot of information that has to go up here that translates to what you're doing right here, because if you prep, scan it, you send it, and then you realize, crap, I can't mill any of this stuff out. Then you have to go back chairside, adjust your prep, and like that'll burn someone real quick where I can't do this, I'm not doing this.
Printing is a lot more forgiving with that.
Yeah, I mean, you can print essentially any geometry that you prep as long as there's draw, and it'll be fine.
Plus, composite sticks to composite so tenaciously. You could add to it, you could remove it, you could polish it back in the mouth. It's not brittle. I mean, resin materials, the way that they're going, are becoming so good. Honestly, I think it's going to be in the next year or so before I might even say for full coverage crowns on posterior teeth, I'm going to switch to printing. But that's me because I tend to be more aggressive or more, I would say, early adopter. But Mike, puck milling. So we've transitioned from same
Everything
day.
always comes back to printing in
Let's
this
go
group.
let's go back to
So
milling.
we've transitioned from same day fast 3/4 axis mills, all about speed, to slower, I would say a lot more accurate 5-axis mills, slow firing instead of speed firing. You know, we were on the bandwagon of speed firing, same day, blah, blah, blah. But we were like, hey, why are we going through this? Like, if we're going to mill it, we might as well just do it right. And so we got tiny little 300 micron, 400 micron tools that mill the anatomy that you can't even imagine this anatomy. It's insane. So tell me about puck mills and what people need to know.
Yeah, I mean, I think one of the misnomers about milling has come because of 3/4 axis milling is 5-axis milling, where we're using 5-6 tools like down to a 300 micron burr tip. Like the fit, the finish of the restorations are amazing. It doesn't just look like a blob, right? Like if you're using a 3/4 axis, it's usually a 1 or 2 tool strategy depending on how it's set up. So you have like a 1 millimeter burr, and that's milling everything. So anything smaller than 1 millimeter, or really 1.2 if you count for a little bit of fudge factor, it's just not going to mill out, right? So you have over milling, you have stuff that doesn't fit, it doesn't seat. You know, and the beauty of puck milling for me is that's not an issue. And, you know, as that has become more adopted, the get in price, so to speak, for a really high quality puck mill, it's like 30 to 50 grand, right? Which is, you know, I'm not saying that's not a lot of money. It is a lot of money, but compared to where we were 5 years ago, where you're at 120 grand, you know, 150 grand, yeah, it's like so much easier to get there. And, you know, even with printing, as far as like a lot of what I do, full mouth rehabs, all in X, great tools for prototyping and stuff. But as far as like what's gold standard for me in doing those types of treatments, it's milling, and it probably will be for some significant period of time. You know, the aesthetics are better with the longer centered zirconia, right? We're centering like 8 to 30.
No, man, you need to do it in 5 minutes.
That works for some things. Oh, second molars.
I would say this though, like it's not a one-trick pony. When you have a puck mill, you could mill dentures, bite guards, mock-ups. You could mill.
But why
full
would you
arches.
mill it?
You would never mill a denture. You'd have to be completely out of your. You could be completely out of your mind. But I'm saying, like,
Why would you even do dentures, Wally?
come on, man.
Just kidding.
I honestly, the only thing that I really mill is zirconia, and typically only full coverage and all in X prosthetic.
It's so efficient, right? And
Cost-wise too, right? I mean, a puck of really good zirconia.
a couple $100. You can get 20 units, 22 units, depending on how large they are, how good you are at nesting.
Get in the green state.
Yeah.
You know, and back to you know milling. The other thing that we do a lot of is zirconia veneers, which I love. You know, I was a lithium silicate or stacked porcelain guy for a long time. So it's either we're prepping and we're going to prep enough for Emax, or we're doing no prep or ultra min prep and it's stacked porcelain. You know, we're milling zirconia at 300 microns thick, hand thinning it maybe to like 200. Once it centers, it's going to shrink 25 to 30%, right? Like you're in that 100 to 125 micron. And, you know, translucency is 50% plus. Like if you
can't bond that.
not a rubber dam.
That's the other misconception is you can't bond zirconia. I'm like, yeah, maybe that's true 20, you know, when it first came on the market and we didn't understand oral phosphates were sticking to the zirconia and preventing primers from working. You know, we've learned a lot with zirconia. You don't need to bake feldspathic or lithium disilicate on the inside anymore. Like it's, you know, the early 2000s. You could.
That's even detrimental. I think what the studies would say now is that bond strengths are lower, right, compared to the protocols that we're using. I mean, aged zirconia bond strength now, if you use modified APC like we do, it's within the error margin of where Emax bonding is. So if you believe you can bond Emax, then the literature tells you you need to believe that you can bond zirconia.
You call it capital MOD modified APC?
Modified.
I like it. Yeah, I like it.
Yeah.
Yeah.
But I mean, that's not a new protocol. It's been around for a decade at this point. There's hundreds of papers on this.
But what nobody talks about is and this is the secret with zirconia, if you go down to like a 0.5 millimeter, say for a full mouth reconstruction where you're opening the vertical and you want a tabletop, be conservative, you could make those restorations 300 to 500 microns thick on second molars and bond them. We're talking about a 3Y zirconia here, maybe a 4Y, but we could bond them tenaciously to the enamel and open that vertical and have something that's going to be essentially everlasting. We know zirconia does not wear, right? It's just an incredible material for opening verticals.
Yeah, I mean, because the data tells you that if you bond 3Y, it can withstand about 1,500 megapascals of compressive load, which at that stage, I'd rather a restoration break than a tooth break, because it's way easier to fix a restoration than it is a broken tooth.
Rather have the tooth be preserved. And so, no, CAD-CAM is not going away. There's not a battle between printing and milling. That's fictitious. It's, everybody's like, oh, Ahmad, you guys only print. We have 3 or 4 mills, 5-axis puck mills there. We got about 20 printers. No, we're digital. We're digital dentistry. We do whatever it is that we need to do to get the job done. And like Mike said, standard of care for all an X is going to be a milled prosthetic. For bruxers in a full mouth reconstruction case, that's going to be probably for us milled zirconia or
second molar
crowns. Like we print when we print and we mill when we mill, and there's no real argument.
They work together though, right?
They work
It's
together.
not an either or. I hate that
to bring
question.
it back to milling, though, one thing I do want to hit on a little bit too is, especially with zirconia, all zirconias are not the same.
Not created equal.
Particle size, translucency, mixing, layer lines. There's all kind of things that if you're going to go the route of making in-house, just do yourself a favor and get a quality zirconia. Maybe it's $50 more a puck, maybe it's $75, but at the end of the day, it's like a couple bucks a unit. Like, just make it easy on yourself.
Sometimes people are so cheap that they just, they walk over $1 to save a penny, because
Forest for the trees,
man. Yeah.
I mean, when you're building your whole practice off of something,
those kind of things matter for sure.
I think the whole milling and in-house fabrication to save money
that's
not the point.
Yeah.
If you're doing it for that, then don't even do it.
It's not cost savings or anything like that.
You're just transferring costs, really.
It's the same whether you're paying a lab or you're paying.
Only a
for this
rep is
equipment
going
and
to say that it's like, you're going to revolutionize your income, or it's a bunch of bullcrap. To me, the most important thing that you gain from all that is, number one, job satisfaction. For me, number 2 is that control and that patient service.
But I think it is a value add, and I think there is money to be made, but it's not in saving $20 on a crown.
Yeah.
It's in what we talked about, same day. The patient doesn't have to come back, being efficient, right? Like, you save money by not resetting the room, right? So whatever that is, $15 to $25, but multiply that by 1,000.
Having your clinical protocol dialed in, where you deliver that crown, your occlusion is going to be spot on, your proximal contacts are going to be good, the margin's going to be good. You're not doing a bunch of remakes or
that goes back to loving
extra
your
chair
job,
time, like you said.
When
right?
I started printing bite guards, do you know the bite guard delivery was the most, like, I knew it was either going to be 15 minutes or an hour. And I didn't, when I had a lab fabricated guard, I had anxiety on delivering that stupid thing. Like, and I'm like, what the heck? When I started to do my own printed guards, every single delivery is 5 minutes.
Yeah, and it's the simplest thing, though.
Easy. You heat it, you seat it, bite down, high five them, check excursives, and it's always golden because we have our protocols.
And I have to confess, though, I was one of those before I started making my own guards, where I would send all my bite records in MIP. Yeah. And then it's the most common question that you get for a bite. I was at a time. Well, they don't. I don't know. Maybe I just was.
Well, they don't. Yeah,
they weren't.
They never talked about that.
No.
They weren't.
No.
They actually, as of a year ago, when I was still at MUSC, using a leaf gauge, taking open bite centric records.
Finally.
They were doing that.
Oh, nice.
Yeah.
I think, our protocols for that stuff and basically everything are battle tested, right? We all practice extensively. There's a lot of educators out there that kind of just, they did some stuff 30 years ago and they read some books and read some research and now they have a training center. But
Yeah, I think one of the misnomers maybe that I've heard people say is, well, everything that you guys do is perfect. Yeah, stuff is like super predictable now, but I've been beaten up and made so many mistakes. And like part of like for me, and I still love practicing for education, some of it is career and, we make money doing that, of course, but it's like, don't make these mistakes that I made. Like learn from all the times that I got beat up, and some of it is like satisfaction and giving back, and like that's I guess a total tangent, but I'm famous for those. I guess I've been told. So
It connects back into why CAD CAM isn't going anywhere and why it's beneficial for clinicians to use it, because it makes you a better clinician, right? You can look and analyze and see why did something not work, learn from that, get better.
okay, but let's talk about this because, I hear this all the time. I don't want to design. I don't want to design. Like, come on, man. How hard is it to design a single unit crown?
It's playing video games.
The software does most of the work for you.
I mean, it's like, I don't understand the mentality. It's like 3 minutes to design a single unit crown, but with AI getting better and the software's getting better, like what we had to do back in the day, and aging myself, there was literally dots and lines on the screen. It was 2D on like the Serac 2.
Atari, right?
The
Come on.
Atari CAD CAM.
No, Atari was more advanced than this stuff, man. And it's like today, it's incredible. And to have a clinician sit down and be like, nah, I can't do that. That's
I
just,
love that. That is such the old man comment to make though. When I was a young CAD cammer.
these guys don't know how good they have it.
No,
man.
you're absolutely right. It doesn't make you wrong, but I love to hear you say that.
One of the things I think too is like if you plan on practicing for more than 5 to 10 more years, whether you want to be digital or not, you will be, because having everything digitized means that we can apply machine learning algorithms, we can do all kinds of things, and we'll get to the point where labs are just not going to make single unit crowns and stuff, I fully believe, because there'll be no money there.
Like, it's already a race to the bottom with like $40 crowns.
So I mean, the AI is the worst point that AI is right now, right? And so, are we going to get to the point where we're doing full mouth rehabs and stuff like in the next 5 years with AI? Maybe. I'd be super surprised. But single unit crowns, inlays, onlays, bite guards are there, bridges are there, probably smile designs.
It'll get to the point where as you're scanning, it's already designing your restoration.
So close to that. And so like, do you want to be ahead of the curve or be catching up? Like if you're learning now and you're scanning and designing and manufacturing now, when the tools get easier, that just means you're ever more faster and you're flying.
And your practice is already set up for it, because let's face it, there is that component as well where scheduling, you have to figure out how to schedule a single visit appointment. How does that weave into? I know.
Yeah.
But unfortunately, we are out of time, fellas. I know you guys are. You guys are great.
We'll have to do it. Let me get the last word.
Go for it.
So you can either go digital and CAD CAM now when it's a value add, or you can wait and do it when you have to. And so that for me is the big difference why I can't understand why any practice wouldn't want to be digital. And maybe you don't want to be like us, like that's fine. You don't have to be like us, but like you can do digital however you want. We think our way is the best, of course, but if not, get a scanner, get a printer, maybe get a mill like this guy if you're a wizard.
If all you have is a scanner though, you've missed the boat completely.
The magic happens after the scan.
What happens after the scan is the single most important thing to define your practice.
Yeah. Casey, what do you got to finish us off here? Words of wisdom, because you're of all of us, you're the one who's never really had anything other than CAD
I've been
CAM.
very lucky to just always use CAD CAM.
He's the youngest on the outside, but the oldest on the inside.
Oh, yeah.
I think we're gonna have a part 2, because we didn't even talk about
You're right.
scheduling.
You're
and,
right. I know.
and just implementing and how that works.
We didn't
really
talk about
well.
why printing's better than milling.
We didn't talk about that
for sure.
either.
That
Yeah.
for sure.
Well, we talked about it a little bit.
What I wanted,
You didn't let me.
what I wanted to do more than anything with this episode is talk about. People think they think of the mod as the guys who 3D print, but I wanted to also talk about the fact that we love milling, and we do a lot of milling. My first love in dentistry was milling. You and I kind of
could pry a mill from my cold dead hand.
exactly 100%. So the reality is that technologies are just tools, right, for creating better patient outcomes, better patient experiences, and milling for us over the course of time has been a essential tool in that process.
But let's be honest. Let's just be honest. Printing has taken over, and we basically only mill. We used to mill almost everything. The only thing we're really milling is like molar full coverage, maybe some anteriors and all on X.
So that transition is happening. I think another one of these episodes in the future that you can look forward to is a true printing versus milling debate, and
Boxing match.
boxing match. Yeah.
Here's how we're going to handle that. We're going to get two patients side by side in the chairs here. We're going to start a veneer case, and we have to finish it that day. And you could do milling and I'll do printing. We'll see. We'll see.
I don't like that.
That's a very odd constraint.
Well, guys, thank you for joining me. A cheers.
Cheers.
Still drinking
Sorry.
this glass of milk here.
Coffee.
Disgusting.
So this is, well, no, I'm not gonna
Yeah.
do that.
Thank you guys for joining us. We'll see you next time.
Thank you.